Thank you so much, Jane. Yes, it is great to be back. 2017 was indeed the last time I was here. It's also the last time I gave a talk in Europe because I then moved to Australia later in 2017. So it's absolutely fantastic to be back and in front of all of you. Let's get it kicked off. So yeah, my name is Nash. I'm a developer advocate at Sonar. Sonar is a set of tooling for static analysis for your applications. So it allows you to run against your projects and tell you when you're doing things wrong or could be doing things better. It allows you to write clean code and hopefully secure and maintainable code as well. We have three kind of things. Sonar Cube, which is a self-hosted version of this. It's free, it's open source, and at least the community edition is. The Sonar Cloud, which is the cloud version, just online, nice and easy. And Sonar Lint lives inside your editor to tell you when you're doing things wrong as you type them. At least that's how it works for me. Me personally, you can find me all over the internet as Phil Nash. Please come and follow me on the various things. Twitter, Mastodon, if anybody's trying to use that. Or just hit me up on LinkedIn. That's cool these days, right? Let's talk a bit about these issues, though. I need to start by talking about the data and where I got this data from, right? I'm talking about the top 5 issues across JavaScript across all of our projects. And by that, I mean thousands of projects. What I actually took was I went to the data team and the Sonar Cloud team, who have thousands of projects on there, millions of lines of code, in fact, hundreds of millions of lines of JavaScript and TypeScript, and asked them just to come up with the top. I asked for top 10, and I'm only going to talk about 5 of them today, but I asked about the top 10 issues that we come up with. Now, those issues are JavaScript issues, but not necessarily like catastrophic bugs. Hopefully, all of our products don't have catastrophic bugs in them. That would be awful. I'm talking about the kind of issues you might see, also if you're an ESLint user, something like that. Those rules that help us write better code. And I just wanted to see what those top 5 were that were coming across in our applications that were, in this case, in Sonar Cloud. These issues, the Sonar itself has 322 issues for JavaScript, different kind of rules. 316 for TypeScript. Most of those overlap. Of course, there's some different ones. And I will cover a bunch of them. The interesting thing is, the top 5 is quite boring, as you might expect. Turns out that very common issues are ones you probably know about and understand and hopefully avoid these days, but they are there. And so what I will be doing is going through them, but possibly not exactly in order. And I've tried to jazz things up a bit in order for us to get through the slightly less fun ones. Because ultimately, at the end of the day, if we can avoid these issues, particularly the more common ones, then we can write cleaner, better code. A clean code is sort of I think, a state that we're trying to attain, hopefully, in our applications. Clean code allows us to build applications that work well in production, are indeed performant and secure, but also are good to work with as well. They're maintainable, they're readable. And this brought me to a couple of quotes that I think I'd seen before online, but I really liked. And this is for a quote back from 1991 on a C++ mailing list by games programmer John F. Woods, who said, "Always code as if the guy who ends up maintaining your code will be a violent psychopath who knows where you live. Code for readability." And I like that. Like, code for readability is the quiet part, is the important part there, not the violent psychopath part. Because there was another quote I really liked actually from a guy named Raymond. We'll get to the other quote in a minute. This actually came in a thread in that C++ mailing list about the comma operator, in which somebody suggested that the comma operator is surprisingly underused because it could allow us to shorten and make things more concise. They were talking about C++. However, this code would work in JavaScript as well if we'd define those variables somewhere else. And they basically said, if you use the comma operator, you can do more than one thing on a line. And if you're doing that inside a conditional, we can use that single line to avoid having to write parentheses around them. And somebody else pointed out that that comma is very useful for that, but if you get it slightly wrong and you put a semicolon in, then it changes the meaning of the whole thing. It breaks our conditional, our single line of it, and indeed in this case it seems to have broken my syntax highlighting as well, which is fine, but and actually helps you find that issue. But if you've ever gone searching for a missing or a semicolon that's there but shouldn't be, you know you don't want to be looking for that because it's almost impossible to find. And that's where we then get to the quote about avoiding violent psychopaths, because I'm absolutely sure at some point in my career I've cursed somebody over a semicolon, and it probably turned out to be me as well. Indeed, that was the other quote. Raymond Chen, on his blog, The Old New Thing on Microsoft, he's been writing on there for years, said, "Design for readability. Even if you don't intend anybody else to read your code, there's still a very good chance that somebody will have to stare at your code and figure out what it does. And that person is probably going to be you 12 months from now." This all points to the fact that code is read more times than it is written, which is an important fact. And it's read as you write it. You have to understand what you're writing at the time. Even if these days we're relying on artificial intelligence to help write that, you need to read the code that it's outputting as it's coming onto the page so that you know and understand it's doing what you want. But that person, could then be reading that code again the next day in review. Somebody else might be reviewing it. You might be reviewing your own code. When you come to change it, you need to be reading and reviewing your own code again so you understand it so you can change it with confidence. Code gets read much more than it is written, and thus it is important for it to be clean and maintainable. So clean code runs better in production. That's part of the point, right? If we've written code well, then it's going to be good when we deploy it. But it's important because it's also better to work with in development. I hope you agree that that is kind of what we want out of our code when we write it. I'm seeing some nods. Good stuff. So what are these top 5 issues? What are we doing to our JavaScript projects that is not helping with this? Well, like I said, I have that top 5, and I'm not going to quite do it in order. And I did add some jazzy effects to help us get through the less interesting ones. So in number 5, should have had a fanfare or something, I don't know. There should be more confetti in the world in general, I think. But number 5, unused assignments should be removed. It turns out, in a surprising number of JavaScript projects, a surprising number of lines of code, assign something, and then assign it to something else later without having used it. That's weird. I genuinely want to say again, I got all this data from the actual live running data of the applications. I didn't look at any of this code because most of it is closed source, and I'm not supposed to do that. I'm not allowed to, and I don't know how to. Although there are some open source projects, because it is free to run an open source project on Sonar Cloud, so I can go and look at some of those things, and this happens. Not with this code, but people will assign and then reassign without changing it. Now there's a problem, or there's a potential problem here, in that we're not seeing something. Now this, it doesn't matter if you assign something and then reassign it later. It's just a wasted line, which is cluttering up your code. But if this function, this other function that's on this page here, is for some reason reaching outside of its scope to use that variable within itself, change it and reassign to itself, then that's bad. Because in order to understand this code, we can't just look at it. We have to go and look into that function and understand its scope and what it's dealing with. And that's bad. That's not good. Plenty of people over the years have been proposing more functional programming kind of methods that we should use. And one of those is that kind of pure function kind of capability. If a function is causing side effects, which this would be if it was using that foo variable or changing it with inside somehow, then that's hard to reason about. And it's much easier if you pass everything that a function needs into it, and so that it will always create the same output. With this current code right now, obviously it's nonsense code, but it's really hard to know whether this is just a simple mistake or a difficult to reason about system. And so that's bad. Some other examples, this is basically the same thing, just a little bit more JavaScript-y. Why would we have that? No reason for that. It happens, though. But this actually shows off a slightly different, like the other side of that kind of other function thing. And this is something I see quite a lot, in which functions return and assign at the same time. This actually violates a couple of rules that we have inside the system. But this is an unused assignment within the scope of the code that it is dealing with. However, what we don't know is what the side effects, what's happening outside of that, and it makes it hard to reason about. So it's real simple. We just don't assign things when they aren't going to be used straight away. Very straightforward, hopefully. But present in a whole bunch of applications. It's okay. Next up, let's move on. Let's just not unuse assignments, it's fine. Next up, in number 4, fourth most popular thing to do wrong in JavaScript applications. I feel like I should have a fanfare or something that goes with this. Whee! Triple equals and double equals. The fourth most common issue is that people are using double equals or bang and equals to compare things. I don't need to talk too much about what the code looks like here, but what I do like to share is this. Oh, it's offline, you bastard. Good. What I was going to show here was and it's online, and I should have just taken a screenshot, was a grid of objects and what happens in their comparison using double equals or triple equals. That claims to have connected, but it's not going to now. Well, that's annoying. I'll move on. Excitingly enough, it also takes control of the mouse when I click on it as well. The grid of things, of comparisons with double equals versus triple equals is great. So down the y-axis and the x-axis are the same amount of objects. And if you're on the triple equals, it's equal just down the middle if you're comparing the same thing. We know this, right? But the double equals has just patches of equality all over the place. It's basically the source of every JavaScript interview question you didn't want to answer. Like, what does it mean if you compare true with an empty array containing or an array containing an empty array? Is that true or false? Who knows? Who cares? But because you shouldn't ever be writing code that compares the Boolean true with an empty array that contains another empty array. It's a nonsense idea. But it is false in this particular case. If you have an array with something in it, then it's true. So we just don't want to use double equals, right? There's a second part to this. If you're making double equals coerce objects that are of different types into the same so that they can be compared, and that's a performance hit. Coercion is not a simple thing for it to do. I saw some performance benchmarks for it recently, and if you have to coerce like an object into something else using double equals, it is 99% slower than just using triple equals, which just checks the type and goes, nope. So triple equals and double equals. Unless you've got very good reason to use double equals, don't. That seems very straightforward. Has anybody got good reason to use double equals? Anybody using it? Good, well done. Yes, we have a good reason. When you have to compare with null. Oh, okay, interesting. And undefined, because it comes to the same thing. Not a bad idea. I think any of these rules are interesting because they always come with trade-offs. No rule in programming is hard and fast, is set forever. But that's interesting. I would consider maybe just checking against both. But which would it gives you more. It shows more of what your intention is, I guess. If you're using that double equals, it's sort of kind of fudging it for you. But if you like, is this undefined or null? You're making it up. I don't know. We can argue about this. I won't argue about it. It's fine. A lot of other people are doing it, so you're right. So, okay, I'm still going in order for now. I'm going to hit number 3. Number 3. I get some more confetti after this, so hey. The third biggest rule violation is that people are checking in. And I'll note that this is code that is checked in, that is going to pull requests or going to the main branch and is being pulled into this tool that is statically analyzing it, is that people are checking in commented out code. Commented out code is clutter at best. It gets in the way of you being able to read what a function is doing because it's sitting in the middle of it or around the outside of it. If you come across a function that has commented out code in it, and you were trying to work out what the function was doing, you probably find yourself trying to work out what the commented out code was doing as well. And that's only going to confuse things. I don't have a lot more to say about this, aside from the fact that we should probably just, if you are doing this, consider how better you could be using your source control. If this is old code that you're worried that you might need back again at some point, it should be in Git or whatever source control you have. That's kind of it. It's confusing, it gets in the way. Let's drop it. So I mentioned TypeScript earlier and how I did ask for the different the top 10 of these issues of TypeScript as well. So I thought this was a nice time to take a TypeScript break, because if commented out sections of code are the third most popular rule violation in JavaScript, turns out they're the second most in TypeScript. Don't know why, because it actually also turns out that of the top 5, 2 in TypeScript are comment-based. In number 5, this isn't necessarily a rule violation as such, but it's a way to track usage of to-do tags. You know, comments like this that say, hey, this really important function needs to be finished, I guess. I'll note again, this is checked-in code. This is leaving to-do comments in there is kind of good, you know, as a way to track what you have left to do. But the fact that it's the 5th highest thing in TypeScript that comes up for people's applications, maybe people aren't doing the to-do. I don't know. It's slightly concerning. This is good to track, but yeah, it's interesting to see that TypeScript are very comment-based, both in the sections of code commented out and tracking those to-do lists. I will come back to TypeScript once again, but I tell you right now, I'm not going to tell you what number 1 is. You have to come and find me later if you want to know that. So let's go back to JavaScript. I'm not going in order, so it turns out I think number 2 is the most interesting, and so I'm going to leave that to be the last thing I talk about. But that means we have number 1, far and away the most popular rule violation, almost kind of 2 or 3 times the number of number 3 or 4 in this case. Any guesses as to what it might be? What do you think is the biggest thing that people in JavaScript are not doing, or doing badly? Doing oldly? Pardon? Console log. Oh, that's a good one. No, didn't come up, actually. Not in the top 10. Interesting. Testing. I think if test coverage was a part of these kind of rules, and test coverage is covered by the cloud, it just doesn't come up in these rules. It might have been an issue, but no. It turns out this actually fits quite well in hand with Daniel's talk earlier about kind of using new syntax to be more expressive and get things more right. And this isn't a very new syntax either. In fact, it's just constant let. Of course, this probably indicates that a whole bunch of that code is in the analysis here is of some sort of legacy code. It may be a bit old. You know, constant let came out with ES 2015 with ES6, and we've been able to use it for a number of years already. But it's absolutely far and away the top kind of issue here. And I think that's an interesting one because I talked about clean code and that kind of maintainability. But what I really think this one does, and I think it's what was been saying earlier, is that these keywords communicate something about what you're trying to do with the code. Yes, you see you nodding. Thank you. It communicates what you're doing with the code. We know when we set up a variable using const that that reference is not going to change. We know that we can change objects that are made a const. You can push things into a const array, but that array itself is not going to be different over the course of the scope of that variable. And when we set something up as const, we are telling other people programming that this is not going to change. We're telling ourselves in 12 months. We're telling violent psychopaths. When we set something up with let, we are saying that this is a reference that can change and that that's important for this particular variable. Var just tells us nothing. It's not broken. It just doesn't tell us anything. It's a little bit like using divs for every single element on your page. You shouldn't, but you can make it work. And so that's what I'd like to see. I just want to see more communication from code bases. Again, whilst looking through all of these things, I do kind of think, I'm not saying we need to drop everything right now and go check all of our code bases and remove every kind of version of var or every double equals, because if it is working right now, it's working for you. However, if you are able to kind of change and improve these things as you go back and work on those code bases, then you can leave it in a better place than it was before. If you do recognize these things in your code bases, then I hope that's kind of, I'm not complaining at you, but you have the opportunity to always leave it looking better, always leave it cleaner the next time around. So okay, I've done the top 4 out of 5, and I got number 2, which I thought was the most exciting. I hope this really hits hard, because I think it is cool. But number 2 is that cognitive complexity of functions should not be too high. Right, I know. I'll get to that in a minute. I like the confetti, though. Funny enough, this is also number 3 in TypeScript, which is good. Like, I think it's important that these things are matched up and... All right, calm down. So, cognitive... It's supposed to finish soon. All right. Does anybody know what I mean by cognitive complexity? Like, I'm obviously excited about it, but ideas. Okay. No. Terrifying. Have you heard of cyclomatic complexity? Is that something you might have heard of at all? That's one. A few, yes. Okay, cool. So we've heard of cyclomatic complexity. Cyclomatic complexity is a way to sort of measure the complexity of a function or of a class or something like that, based on the number of paths some data can take through that. And it comes up with a score. And in this case, we have a function here that is a sum of primes. It takes a number, and it adds up every prime number that is less than this number. And so cyclomatic complexity is calculated by adding 1, because it's a function. It's a good start. And then we get another 1 here, because we have a loop. We get another 1 for conditional. We get another 1 for the conditional in there. And then, we have a loop, another conditional, and then a final conditional. This scores 5 overall in cyclomatic complexity. There's 5 different routes through this function. If we were to write coverage, a test that would cover this, we'd only need to write 5 in order to cover it completely. And that's what it does. And cyclomatic complexity is supposed to be some kind of idea of complexity, right? But we have functions like this as well. This is a simple function that returns some words based on a number you pass in. So if you pass in 1, it returns the word 1. If you pass in 2, it says a couple, 3 a few, 4 many, 5 lots. And cyclomatic complexity says, for each one of the function and then the switch, each case in the switch, we're going to add 1. And so this function also has a score of 5 and is apparently as complex as this one. That's not entirely true, is it? Like, that's pretty simple. We can work out what that does by really glancing at it. That one we really had to kind of read into. It's got nested loops and 2 nested conditionals inside there. That's a switch statement. So cyclomatic complexity is not great at measuring understandability, measuring that maintainability. And that is what cognitive complexity is intended to do. So cyclomatic complexity measures that number of paths through a function. Cognitive complexity is supposed to measure how easy it is to read and understand a function. And we'll see how it still adds up kind of a score in a similar way to cyclomatic complexity. But cognitive complexity does it differently. It creates that score, and this is kind of a brief overview of it. There's some more complexities to it. But basically, it creates a score by adding 1 for breaks in a flow. That's a loop or a conditional, a bit like in the cyclomatic complexity. And secondly, by incrementing a nesting score. See, what happens here is every time it nests, that nesting score goes up. And then if you hit another break in the flow, it adds 1 for the break, and then it adds the nesting score as well. And so we can see that in our sum of primes function here, where you don't score 1 for the function existing in the first place. That's a good start. I like that. There's always going to be a function. But in this case, our first for loop scores 1. That's just a break-in flow. But it's incrementing the nesting in the back end. So we then get to our second loop. That is going to score 1 for its nesting level and 1 for being a loop. So it's 2. And then we get to the conditional that's inside 2 loops. And that's scoring 1 for being a break-in flow and 2 for the nesting, so it scores 3. Finally, we drop out of one of the loops, come back to the conditional, and we score 2 because that's 1 nesting back inwards again. And the ultimate cognitive complexity of this function is now 8. The switch, on the other hand, scores 1 because it doesn't nest its break and flow once, and we can just quite clearly see what it's doing. If you were to start putting loops inside those case statements, that's going to cause some trouble. But sort of just intuitively, between cyclomatic complexity, which scored these equally, and cognitive complexity, which kind of scores this one much lower than the previous one, that's an intuitive kind of idea that cognitive complexity is better about that understandability. And so the rule says that cognitive complexity of functions should not be too high. Too high, in this particular case by default, is 15. So our sum of primes function back there only scored 8, so actually wouldn't really flag this rule. But 15 is the threshold. I think it's kind of interesting talking about a threshold like that, because like, you can never pick the right number for a threshold like that. You have to pick something. And once you do, you kind of have to treat that as it comes, right? I actually have a little bit of example here with that. There's my code. This is actually the code that I'm using on the slides to show the confetti. I thought, I must need a project for this. I was writing something about confetti. Turns out this code, and it's quite a long function actually, so this is a Reveal.js plugin, and so at the bottom here we just kind of create a plugin thing, and on init it does one thing, which is said, on the slide transition, we'll run this slide transition end function. And that slide transition end function is about 87 lines long, which is honestly too long anyway, but a lot of it's settings. And it's currently lit up in the editor there because I have ESLint and the Sonar.js plugin for ESLint, which is showing me cognitive complexity. In this case, it's actually only breaching that by 1. The cognitive complexity of this function is 16. And it's for a couple of reasons. Firstly, the entire thing is wrapped in one conditional, which is adding the nesting to everything straight away. And then secondly, we have kind of like some ternaries here. They're also conditional, so they're also going to score, in this case, 2. Then we get another conditional here. We get a conditional and an internal function here in order to do an animation frame. And over here, we've got a set of settings and an array, which we then loop through as well. So whole bunches of reasons to score points against this. But what I wanted to talk about with this particular thing is that I can actually fix this in like 1 line. If I just kind of abstract something like data set to integer. Whee! I can spell. We'll take the element. We'll take the an item in the. So this is trying to factor out like these ternaries here. In this case, the particle count, the number of bits of confetti to throw. We look at it in the data set using confetti particle account, and we either return an integer parsed out of that or a default. So we need the attribute and then a default. And once we've done that, we can just basically we'll do l.dataset attribute. If that exists, then we'll do parseInt on it. Nope, parseInt on it. And if it doesn't exist, we return the default. And we can then just replace this one line here with our dataset to integer function using the current slide, the confetti particle count, and a default of 200. And if I save that, it probably works. It might not. That's fine, doesn't matter. Because what we notice is we've dropped the complexity. It's now 15. I dropped that ternary out, I extracted it. The function now makes more sense. But we actually haven't fixed this very well. Like it's still an 85-line code, 5-line piece of code, and it's horrible to read still. And what that implies is, basically, if you breach that complexity, it means you've gone a little bit too far, and it's worth looking at again. This is a function that we could actually fit much better by extracting a bunch of things. So we've got integer data attribute or default. We've got an array data attribute or default, because we can add some colors into it. And then functions for doing a small burst of confetti, a large burst of confetti, and a medium burst of confetti. This has this array of settings in, but it doesn't matter too much. That's just data. And then our on-slide transition end function becomes 20 lines of code, and it's a lot nicer to read. In fact, the cognitive complexity of this is now, I don't know, 4. Yeah, it's much easier to read. We have abstracted things, and we have to go and read those to find out what's going on, but it is a better experience all round, and we can see what we're dealing with here. And honestly, I could also rewrite things to avoid that main outer conditional as well, which would probably be helpful. So that's our idea of cognitive complexity. It's a way of measuring how understandable it is, and if you breach that kind of level of complexity that we decided 15 was right, it is worth going to look at that function and seeing what you can do with it to make it more understandable. Cognitive complexity I think it's a great measure. It's been there have been papers on it that kind of prove it to work better over cyclomatic complexity, and so I think it's worth looking into in order to make our code more understandable. And so those are the top 5 issues. Unused assignments should be removed. Assignments that are useless to you should not be there. And if they are, in fact, for being used somewhere else in scope, that's a bad thing. Triple equals, we can talk about the double equals another time. Leaving commented out code in your code is a bad idea, and we can handle that with our source control. Cognitive complexity is something I'd love for people to look further into. And finally, let's drop those vars. Let and const are the future, and have been for 8 years. Cool. There are some tools you can use to deal with this. As I said, Sonar Cloud is free if you have open source code that you want to kind of put through it. Sonar Cube has the community edition, which is free if you want to run that against your own proprietary stuff and check it out. And Sonar Lint can live in your editor to tell you these things as you're writing them. Of course, I want to see more simple code and more maintainable code everywhere. So if you're already dug into the ESLint ecosystem, then obviously ESLint is great for you. And if you want to get cognitive complexity into your ESLint settings, then check out the ESLint plugin Sonar.js, which will give you cognitive complexity as well as a bunch of other rules that we've written to help what we think will make more maintainable JavaScript as well. If you only want the cognitive complexity one, you can just enable that, of course. Some of the links. There is a paper on cognitive complexity, which I've read a surprising number of times myself. I don't read papers, but I've been through it like twice already. That article by Raymond Chen talking about code readability is short and sweet and just nice to read. I will share out these links online later, by the way. Obviously, these aren't links that you can see right now, but that's what I'll be sending you. There is a whole list of JavaScript rules that Sonar looks at. And finally, I did publish the Reveal.js confetti plugin. So if any of you want to give a talk using Reveal.js and have bursts of confetti, it's also there available for you. I'll be updating it to the nicer reading code soon. Ultimately, clean code, I think, is a great thing that we should be aiming for with our applications and avoiding these issues and reducing the number of issues in our own applications. And like I said, I'm not asking you to go away right now and drop everything and do a sprint on removing var and changing it to let or const. That will be a waste of everybody's time. But if you clean things as you code, if you get these notifications as you're working on stuff, then you can always leave your code base in a better place after you leave it, after you've committed it. And refactor those complex functions. If you know about the cognitive complexity of things, then you can go and refactor them and make your life better in the future. Ultimately, aim to code for readability, because you're the one that's probably going to read it, and if it's not you, then it's somebody you work with, and if it's not them, it's a violent psychopath who's going to kill you. Ultimately, code for your future self, and hope you're not violent. We're doing it all for ourselves, really. And that's all I have for you this afternoon. Thank you again for having me at JSday. It's an absolute pleasure to be here. Enjoy the rest.
Thank you so much, Phil. That was very interesting. I'm going to read more about cognitive complexity, definitely. Are there any questions in the audience? Nothing? Well, I have a couple of questions. Yeah, so I noticed that with cognitive complexity, length of function is not being taken into account?
Not necessarily. But like if you wrote a 1,000-line function in which everything was just a step after the previous thing and nothing ever like deviated from that, it's pretty understandable. You know, like the sort of dream of a procedural programming kind of previous life, I guess, in a way, where just every line ran after the previous one. It's understandable. It doesn't make it necessarily the best thing, but cognitive complexity is not going to complain about it. But neither would cyclomatic complexity as well. Like it would score 1 for cyclomatic and 0 for cognitive, even though it's long and worth reading. There's an interesting thing I meant to bring up, and I never put it in the slides in the end, but there's a paper which I meant to read and didn't, that talks about the different kinds of complexity. And I think that's interesting, because there's inherent complexity in the things that we try and do, and we can't necessarily escape the inherent complexity of the problem we're trying to solve. It's the accidental complexity that we add on to it that causes us the problems. It turns out if you are building something complex, and you're in a complex domain, how you write the code isn't going to make the domain any simpler. But how you write the code can make how your code base ends up acting. And so the paper's called No Silver Bullet. I think it's from a bunch of years ago. And I say I haven't entirely finished reading it myself yet. But that idea of like the complexity that is part of the problem we're trying to solve compared to the what we actually write is important here. And so if there is no complexity in the problem we're trying to solve, and you can just do it all in a set of steps, then it's not super complex around. But you could make it more complex if you tried hard. And so yeah, that's length of function doesn't necessarily matter, but kind of what you're doing inside that function does.
Thanks. And what about the other way around, like trying to make a function less complex, but going so far that it actually becomes more complex at one point?
That is not measured by that kind of thing. What you can do is start to measure the cognitive complexity of kind of the application as a whole, or the program as a whole, or a class as a whole, depending on what you're doing with it. And if it turns out that you're just farming things out into far too many places and getting the wrong abstraction, hopefully it's something you kind of recognize at the time, but also it will probably come up on that kind of more aggregated complexity reading of the entire project. What you'd aim is to decrease complexity overall by abstracting things out and moving them around. But I don't have a better answer than that right now. Just hopefully, I think my kind of point with this kind of, as you breach the complexity kind of limit that a tool might give you, is that gives you the impetus to think about that function harder, and it gives you a good reason to do it. It's something you can put on your backlog if you're not ready to do it right now. But once you do consider that, that means that the entire focus of dealing with that is to make it less less complex. And so hopefully, with all the other things you might have in place in your pipeline, if you're pairing, if you're doing a code review, then we avoid kind of making it complex in other ways as well.
Thanks. Any questions? No? Oh, in the back.
Yeah. What's between top 5 and top 10 issues?
What's between them? What other things turn up? There's a bunch of interesting. I've got a spreadsheet. It's not very exciting. No, I'm not going to show you those right now. I tell you, interestingly enough, on the top 5 TypeScript one, in at number 4 was actually a React issue. Funnily enough, it's become that popular. The issue, again, is down to you to decide whether this is an issue, but it was down to using binding or arrow functions in properties of a component. The idea that if you are rendering that component many times, then you are making lots of bindings, and it's ultimately going to cause a performance issue. And funnily enough, that comes up as number 4 biggest issue in TypeScript. So it was very interesting to see that React appeared there on TypeScript. It didn't appear at all in the top 10 for JavaScript. And so maybe that means a couple of things, that people are writing React applications more in TypeScript. I don't know. It's impossible to sort of read too far into that data. But I did think it was interesting that, yeah. And to be fair, like that problem also, like I say, it's sort of a debatable one as well. It used to be kind of mentioned in the React documentation as something you might not want to do, but isn't necessarily a problem. Like if you find it's a problem, that's where you should refactor out your bound functions within properties. But it's actually gone from the new React documentation. I think with the further, it was more of an issue, particularly binding functions in class-based components, and so as everything seems to be functional components in the new documentation, or heavily weighted that way, it's less of an issue. And so something to be refactored away, but yeah, that's one of the other ones on the list. I'll share the rest with you if you find me later and find my laptop. I've got them all there.
I see there's one more question in the back.
Hi. Do you reckon that fixing some of these issues will also fix inherently the complexity itself?
That's entirely possible. I mean, if we think about the unused assignments kind of thing, if it turns out that it's not just a random line that shouldn't be there at all, if it turns out that the assignment is being done outside of in a function that's wake up, fingerprints gone. If it turns out that assignment was in fact causing a side effect somewhere else, or within a function is causing a side effect, then rewriting it so that that everything is a bit more linear, is a bit more passing all the arguments to a function that it needs rather than reaching outside of scope and things like that, then yes, I believe that would ultimately improve on the complexity of the application. But like removing commented out code is not going to change the complexity of an application, although still arguably like it's more complicated to read something that has extra stuff in it that you didn't need in order to understand what's actually going on. So yes, yeah, overall, yeah. Maybe like if you're changing var to const, that's not going to help. But like there are places where that complexity will be reduced if you do in fact refactor something out so that it is not failing one of those other rules.
Right, thank you so much. Phil Nash, everyone.
Thank you.